Hello students, in this video we'll solve some sums on numerical value type question which are important for the JEE Advanced examination, and at the end of this video we'll solve some previous JEE questions on numerical type or integer type. So this sum, if a equal to cos pi by 2n plus I sin pi by 2n and z equal to limit n tend to infinity pi by 2n 1 plus a square up to a to the power n minus 1, find mod of z square. So first of all, there are number of ways to solve the sum. Like we can use the GP formula, a to the power n minus 1 by a minus 1, and we can proceed. And I am showing the short method of solving this sum. Better we'll use the definite integral as a limit of sum. So let us consider z equal to limit n tend to infinity pi by 2 into 1 by n summation of r equal to 0 to n minus 1 and cos theta plus I sin theta, that is pi by 2 into r by n. Better in this form, because in this form we know that r by n will be converted to the x and this is integration 0 to 1. Therefore directly we can write pi by 2 into 0 to 1 e to the power I theta, that is I pi by 2, r by n is converted to x. So if we apply the integration of this, so pi by 2 and e to the power ax is 1 by a into e to the power ax formula, so 2 by pi into I into 1 by I here, and e to the power I pi by 2 x 0 to 1, and if we apply the upper limit and lower limit, and they are getting cancelled, these are getting cancelled, and it is coming to be 1 by I, and here it is upper limit and lower limit if we apply, so e to the power I pi by 2, actually cos pi by 2 plus I sin pi by 2, that is coming to be I cos pi by 2 is 0, I minus 1. So if we can divide by I, that is 1 plus I, therefore mod z equal to root 2, and our question was mod of z square, so this is coming to be 2. Let's go to the next sum, next type sum. Let us proceed. In this particular case, find the equation of the circle which touches the line and another two line as a normal. And as we know that the normals intersect at the origin, so first of all we have to find the equation of the normals in Cartesian form, so we can solve the sum very easily then. So let z equal to x plus iy. Now let us use the first normal to the Cartesian form. So in this case we can write 2 minus I, z means x plus iy, equal to 2 plus I into z bar means x minus iy. So if we just multiply and calculate, we are seeing here x equal to 2y. If we calculate, just simple can go to the cancellation plus minus, and we are getting that x equal to 2y, and this is one normal. So let us go to the some another normal. Another normal is here, it is given. This is another normal. So let us convert it to the Cartesian form. For Cartesian form, let's see here. Here if we apply the Cartesian form here, so 2 plus I into x plus iy plus I minus 2 into x minus iy minus 4i equal to 0. So by multiplying this, all terms are getting cancelled and remaining terms are just some imaginary part, and if we take the common, we are getting the 2y plus x minus 2 equal to 0. So let us consider this is the number 2, and as we know that the these two are the normals, and the intersection of the normal is nothing but this is one normal and this is suppose another normal, and intersection of the normal is the center, and this is suppose another tangent. Now intersection of the normal surfaces is it's a center. So let us solve number 1 and number 2. This is number 1. If we put x equal to 2y, here if we put x equal to 2y, 2y plus 2y, 4y, 4y equal to minus 2, so y equal to half. If we put y equal to half, we are getting x as 1. Therefore, we are getting center as the 1 comma half. 1 comma half it is. Now we have to change the tangent to the Cartesian form. So tangent is iz plus z bar plus I plus 1 equal to z. So I into x plus iy, instead of x if we put x plus iy, if we instead of z, so x minus iy plus I plus 1 equal to 0. So we can write this as 1 plus I into x minus y into 1 plus I plus 1 plus I equal to 0. Therefore, x minus y plus 1 equal to 0, which is the equation of the tangent. So, length of the perpendicular is the radius. Therefore, in this case, we are getting r. Radius r equal to, here r equal to, is a perpendicular distance from, it is a perpendicular distance from 1/2 to the straight line. So, r equal to, directly putting the value, plus 1 by root over a square plus b square. So, r equal to, here 3 by 2 root 2. Therefore, circle is, equation of circle is in the form of circle, that is, we are getting here 3 by 2 root 2. Now, let's go to the next sum. This sum is a JEE Advanced question of 2022. So the question is, let z be the complex number with the non-zero imaginary part, and if this expression is a real number, then you have to find the value of mod z square. So in this case, how to solve this sum? Let's see. First of all, we are seeing that the numerator denominator power is same. So we have to cancel the power of the numerator. It means we have to make the numerator power smaller. It is always applicable. In all cases, it is applicable. So what to be done? This equal to the expression, I am not writing so much. The expression equal to, we can write this as 1 plus, if we manage, actually 4z square is getting cancelled, plus 2 plus 3, it means it is coming 6z divided by 2 minus 3z plus 4z square. So we can write this as, this belongs to real number. So z by 1 is the obviously real number. So z by 2 minus 3z plus 4z square also belongs to real number. If any complex number is a real number, then z equal to z bar. That we know. So we can write this as, therefore we can write that z equal to z bar means z by 2 minus 3z plus 4z square equal to z bar means this bar 2 minus 3z bar plus 4z bar square. If we just cross multiply, we are getting just 2z minus 3z z bar plus 4z bar z square. No, sorry, it is z bar square, 4z z bar square equal to, in the right hand side, 2z bar minus 3z z bar, and here it is coming plus 4z square z bar, and in this case we are seeing that this value is getting cancelled, and finally whatever the value we are getting, this is coming to be, if we take just everything one side, we are getting 2 into z minus z bar and minus 4z z bar into z minus z bar equal to 0. So if we just take common, we are getting here z minus z bar into 1 minus 2z z bar equal to 0, as z not equal to z bar. The reason is that here it has been given that it has non-zero imaginary part. It means it is not the real. That is why z not equal to z bar. Therefore, you can say 1 minus 2z z bar equal to 0. Therefore, z into z bar equal to half. Therefore, mod z square, z into z bar is mod z square equal to half, that is 0.5. So answer is here 0.50 is the final answer. Let's do another sum. This also came in 2022. Actually, this chapter is extremely important chapter. So let's solve this sum. This sum given that z bar is the conjugate of this, and in the set of complex numbers are number of distinct roots of the equation this. So you have to get the different values of z satisfying the above equation. So let us write here, that is z bar minus z square equal to I into z bar plus z square. So if we take common I here, left hand side, if we take z bar common, we are getting 1 minus I, and that's equal to 1 plus I into z square. So z square equal to 1 minus I by 1 plus I into z bar. Actually 1 minus I by 1 plus I, if we multiply 1 minus I in the numerator denominator, denominator is coming 2, numerator is coming minus 2I, so it is coming minus I. Therefore z square equal to minus I into z bar. Let z equal to x plus iy. Let us write let z equal to x plus iy. So we are writing here that z square means x plus iy whole square, that is x square minus y square plus I to xy, and in this case in the right hand side minus I z bar x minus iy. Now if we just equate the real part and imaginary part on the both sides, we are getting x square minus y square plus y equal to 0 and x into 2y plus 1 equal to 0. So from this part we are getting either x equal to 0 or y equal to minus half. When x equal to 0, just put x equal to 0 here, we are getting y equal to 0 or 1, and when y equal to minus half, just put y equal to minus half here. If we put y equal to minus half here, we are getting what? So x square minus 1/4 plus, that is minus half, y is minus half equal to 0. So x equal to, we are getting plus minus root 3 by 2. It means 4 solutions. Therefore answer is the 4 solutions. So total answer is this. 4 solution is the final answer. Therefore this is the answer of this integer type is a 4. So everybody, this type of videos I'll get continuously, so you just subscribe my channel.